This is a prerequisite skill for being able to do later lessons, specifically graph analysis based on equations. Basically, we need to be able to tell what values for x make a function positive and negative. And these values are tracked using a sign chart, which is just the plus and minus line of the three-line chart. So let's start with a little how-to create a sign chart. First, factor the expression. If possible, sometimes it's not. And sometimes it's not needed because it's already factored. Find zeros or undefined values. And mark them on the sign chart. Pick one test point. Really, I should say test value. Between each zero and plug it into the equation. To determine if each factor is positive or negative. And then lastly, determine if the overall function is positive or negative in that interval. And mark it on the sign chart. Here are some key facts to know when creating sign charts. Exponential functions, that's e to the x, 2 to the x, etc., are always positive. Logarithmic functions, so that's ln x log base 3 to the x, etc., have the following pattern. Undefined when x is less than or equal to 0. Negative when x is between 0 and 1. 0 when x exactly equals 1. Positive when x is greater than 1. Also, just be aware, as x gets bigger, the exponential function gets bigger too. So, for example, the natural log of 5 is going to be bigger than the natural log of 3. Okay, anything positive or negative, well, except for 0, raised to an even power, so that's x squared, x to the 4th, x to the 6th, etc., is positive. There are some rules involving square roots. Square root of a positive is positive. Square root of 0 is 0. Square root of a negative is undefined. However, for cubed roots, cubed root of a positive is positive. Cubed root of 0 is 0. Cubed root of a negative, still negative. This holds true for all odd roots. This holds true for all even roots. Other random factoids. If the denominator of a function is 0, so for example, 1 over 0, f of x is undefined if the numerator is 0, so like 0 over 1, f of x equals 0. Finally, absolute value of x is always positive. So we're going to use these rules to create some sign charts. So our first problem, these are examples. Create a sign chart. So this just means record positives and negatives for f of x equals x squared plus 3x plus 2. So the first step on our previous page is factor the expression. If we can indeed. So this is x plus 2, x plus 1. Now what we're going to do is we're going to find the zeros. So remember that anything times 0 is 0. So if this whole factor equals 0 or this whole factor equals 0, then the whole thing equals 0. So there are two zeros. And now we want to mark them on the sign chart. Make sure you do them from left to right, just as if it were a number line. And now it says to pick one test value between each zero, so that actually includes over here between this 0 and negative infinity as well. And we are going to just pick a number, so let's call this over here, let's say this is -3. Let's pick the number -3. And we're just going to plug it in, make sure you use the factored form. We just need to figure out overall positives and negatives. So using the original f of x equation, this is going to be -3 plus 2, -3 plus 1. We could have used any number less than -2, so -1,000,000 if we wanted. But we don't have to actually go and multiply and add all this out in order to figure out if this overall number is going to be a positive or a negative. All we have to do is figure out plus and minus. So -3 plus 2, we know that's going to be negative, and -3 plus 1 is also going to be negative. So a negative times a negative, that gives us a positive overall. All we really need to know here are the negatives and the positives. So here, let's pick a number in between 0 and -1. Or excuse me, between -2 and -1. So really the main number that's in there is -1.5. So let's come on over here, let's try to figure out f of -1.5. So it's -1.5 plus 2, -1.5 plus 1. We can see that this -1.5 plus 2 is going to be a positive number. -1.5 plus 1 is going to be a negative number. So negative times positive, negative overall. Our final one over here, we just need any number bigger than -1, so 0 is a perfectly good number. 0 plus 2 is a positive. 0 plus 1 is a positive as well. Positive times positive is a positive. And there's our sign chart. This right up here, the top positives and negatives, and then the numbers for the zeros, that's the actual answer. What we're doing down here is we're showing work. There are shorter ways to show work. That's totally fine. If you just have the positives, negatives marked down here, that's perfectly acceptable for showing work. So let's do another one. Create a sign chart for f of x equals 6x squared plus 24x. So rather than doing our diamond or our box to factor up here, we've got common factors. So 6 and x are in both of them, so 6x can be factored out. And we've got x plus 4. So now we find our zeros. 6x equals 0, x equals 0. X plus 4 equals 0, x equals negative 4. And we mark those on our sign chart. So now we just pick a number smaller than negative 4. So let's say negative 5. So we've got 6 times negative 5 plus 4. So this is a positive, this is a negative, this is a negative. Negative times a negative is a positive. Between negative 4 and 0, let's call that negative 1. You could have picked negative 2, negative 3, any number between negative 4 and 0. So we've got 6, negative 1 plus 4, positive, negative, positive, negative overall. Any number bigger than 0, let's say 1. So that's 6 times 1, 1 plus 4. They're all positive. Right like that. By coincidence, they happen to end up being the same pattern up here, but that's simply coincidence. And now one of the things you might wonder is why can we just take these negative and positive patterns and say that this is positive for the entire interval? Well, the deal is that we found where x equals 0, or excuse me, where f of x equals 0 by finding these zeros over here. And because we have a continuous function, the only way we can get from a positive number for f of x to a negative number for f of x is to go through 0. This is the intermediate value theorem. And so if we know that the only zeros are here and here, and we know there's a positive number over here, then f of x has to be positive for all of these numbers until it passes through a 0 to get to potentially being negative numbers. Okay, for our next one, let's create a sign chart for g of x equals x plus 3 over x minus 5. Now the key thing here is that we are interested both in zeros and in undefined values. So we're interested in x plus 3 equals 0 or in x minus 5 equals 0. Because where there's an undefined value, it's also possible to have f of x switch from positive to negative. So mark that on our sign chart, negative 3 and 5. A number less than negative 3, so negative 4 plus 3 over negative 4 minus 5. That's going to be a negative divided by a negative. Negative divided by a negative, still positive. Between negative 3 and 5, 0 is a good one to use there. So we've got 0 plus 3 over 0 minus 5. So that's a positive and a negative. Negative overall. Number bigger than 5, so 6 plus 3 over 6 minus 5. That's a positive, positive overall.